Okay, so hello students, how are you doing? I am not using Illustrator on this one. I am instead going to be using draw.io. Now, if you really want to make an account, you can, but I'm just going to make a new program anyway, just a new diagram just for the sake of showing you this. And I will just show you this, and we're just going to make a game of hello? Create new diagram. Tic-Tac-Toe. So, we're going to make ourselves a new diagram of tic-tac-toe. Over on this left-hand side, we've got ourselves general shapes. I can simply click and drag a shape down, and I can click and drag like lines, and if I want to see this little light blue dot, I can click and make a bend in it, and it will automatically make more light blue dots in between each line. So I can keep making more dots like this. If I click and drag one of these dots over here to the actual object, see how it turns green. Now, when I move the object, the line will move with the object. Yes, I know Illustrator quit unexpectedly. I told it to quit. So, that's just the simple tools that we're going to be using here. Of course, on the right-hand side, we can change colors and whatnot. Not going to get too bottled down into the actual way that this program itself works, because that's not the lesson today. The lesson today is we're going to break things down like a computer. So, if we're going to think like a computer, we have to remember a couple of key things. One, a computer will do exactly what it is told. If you tell it go forward, it goes forward. It will not stop until it has another direction. Also, it will go exactly in the order of directions. So if you say jump and then turn left, it will jump and then turn left. It will not turn left before it jumps. It will go in order as it is told. So, if we're going to make code out of these, computer programs, we have to be able to visualize what it is we're trying to do in the order we want. So, I am going to pick what everyone considers a very simple game of tic-tac-toe. And I am going to show you step by step by step what it is we have to do. Now, a couple of rules when it comes to, making yourself a spreadsheet. You generally want to have a legend. So let's just say we have ourselves a start point, okay? And we also have ourselves a, something the player does, right? So there's our player. I'll get some more text, and I'll just say this will be the computer. Whoops. And then let me say, okay, this will be logic. We'll just say logic. Yes and no paths. And then, of course, at the end, we have to have an end. We have to either win or lose, right? So we have 5 different things that we're going to do. Now, general design philosophy when it comes to making some sort of spreadsheet or logo or flow chart, you kind of want to make it easy to read and understandable. So let's have every single one of these guys be not only a different color, but a different shape. See, because if I have a good flow chart, examples, there we go. Oh, look at this. Look at this. Start, customer arrives. It's very easy. Everything is labeled. We see a yes and a no path. It makes sense. We know where we're going. There was no confusion here, right? We start here, we end here, we follow the paths of the arrows. And boom, there it goes. Now, let's confuse that with a bad flowchart example here. Where, oh where, oh where. Okay, well maybe if I don't have to Google through this. Yes, and this guy right here. Where do I start? Where do I start in this jumbled mess? Where do even some of these lines go? See, some of these are straight, but then some of these have angle bends, and I don't know, this one I think goes all the way over here to that one, but... Oh, and this one's going overlapping, and it's so confusing. I can see that there's a difference between these rounded ones and these square ones, but what is the difference? What does a rectangle mean? What does a rounded rectangle mean? What's the difference? I don't know. Why does this one have 2 splits coming off of it? What determines this one and what determines that one? It's just terrible, confusing to look at. So, we're going to make sure we have nice little things. So, I don't know, maybe Maybe the start, maybe start is, I don't know, a green circle. So I'll just make that a green circle. I don't know, maybe our player is a rounded rectangle and it is orange. Maybe our computer is a hexagon, and a hexagon that is, I don't know, yellow. Then, I don't know, maybe we have ourselves a diamond, and our diamond is gray for logic. And then, of course, our end will be, screw it, we'll make our end a cloud. I don't necessarily care what shape you use. I'm not going to be that mean or angry about it, but we need to make it so that we can guarantee that we understand that everything is different. And we're not going to ever confuse the start for a logic. We're never going to confuse the end for the computer, so on and so forth. So, let's actually start. So, let's just say, start game. So, and I'll just double click in here to say start. So here we go. Here's the start of Tic-Tac-Toe. Oh, by the way, I guess I should say this is Tic-Tac-Toe flowchart. There we go. So we know we're playing a game of Tic-Tac-Toe. So, Tic-Tac-Toe, what is the very first thing that happens in Tic-Tac-Toe? The very first thing is you have to have the grid, right? You have to physically have a board to play on. So I guess the first thing we should do is we should have the computer. We're going to assume that this is going to be a two-player game here, but we're just going to have the computer, draw board. So at the very start of the game, I'm just going to simply click from one arrow to the next, and boom, now I have an arrow going down there. So at the very start of the game, we're drawing a board. Easy peasy lemon squeezy, right? So then, what happens? We have to decide whose turn it is, right? So, who goes first? Player 1 or player 2? We're going to say player 1. Do you want player 1 to be X's or O's? For this situation, we'll just say it's, X's turn. So, I'll tell you what, I'm just going to copy that, copy and paste it, but I'll just say, actually, I'll just say select square. There we go. So that's the next thing we have to have that happens. We select a square. Now, there's going to be a couple of things that we have to figure out. Because, can you put an X on top of something that already has an O? No. So we have to have ourselves a logic question then. And our logic question would wind up being something along the lines of, is move valid? And there's going to be a yes path and a no path coming from this. So, we got ourselves a yes path and a no path. So what happens if it's no? What is the computer going to say? The computer is probably going to say something like, pick again. So, if no, and we're going to pick again, and it'll make us select a square. I'll just double click that and I'll say no. So if we have no, pick another square. Okay, is it valid? No, they picked the same square again because they're stupid. Select a square. Is the move valid? No. We have ourselves a way to keep going back around that. So then, we have ourselves, if that's the no path, let's go to the yes path. So what happens if there's a yes? Well, okay, so if they selected a valid square, what happens? Okay, well, I guess now we need to figure out whose turn it is. So we're going to have ourselves another question. So if no, so we'll just move this over here. And now we'll say yes. So instead of, is it X's turn? So now there'll be a yes path and a no path, right? So if it's X's turn, what do you think we're going to do? If it is X's turn, put X in square. Easy enough. If it's a yes, we're putting an X in the square, right? So yes, put X in square. But what happens if it's not X's turn? If it's not X's turn, then what do we put instead? We're going to put an O in the square. So instead of putting an X in the square, we will put an O in square. And then after that, their turn is over, right? There's no other way to make a turn. Like, X can't go twice in a row, right? So, we're going to have to, have a thing that says, you know, switch players or something, right? So switch player. So it doesn't matter after whose turn it is at this point, it's going to switch players. And then also what's going to happen? We're going to have to deactivate that square, right? We're going to make that square no longer valid because they can't pick it again. So deactivate square. So, boom. And then, of course, what happens after they select a square and it gets deactivated? Well, we could go all the way back to select a square, but we have to check something before we do that. Tell me, once you put something in, do you go and become and have another person select, and then after they select, you check to win? No, you check to win right when you select a square, right? So, let's go and say that. So, we're going to have to ask ourselves a question. You know? Did player get 3 in a row? Okay? And that's going to be a yes or a no, once again. And of course, if there's a yes, what happens? The player wins. If not, we keep going. So we'll just say, you know, if so, player wins. Whoops. Player wins. So if yes, player wins. But what happens if there's a no? Well, there's actually a couple of other things. We have ourselves actually another question. If no one won, tell me, are there any, hit enter, any remaining? Are there any remaining? Are there any squares? So, because if there's any squares remaining, then if there's a yes, and let me just go back to select a square here, and let me just drag you over. Because if there's any squares remaining, they get to pick again. But if there are no squares remaining, then obviously we've hit ourselves a draw. And then, of course, we can ask the computer if we want to play again or something. So, I don't know, we'll just ask ourselves another question that says, you know, play again. So, whoops, we'll just draw a line down there and a line over here, because whichever way it happens, they're going to ask if we play again. And if we say yes, where are we going to go? We're going to go all the way back to draw a board, right? So let's go back up there. Let's draw ourselves a board. Come on. I am not a fan of the way it decided it wanted to make that. There we go. So if yes. Oh, come on. Double click that. Yes. But if no, well then, if no, we're going to, you know, say game closes. Because the game's just going to end then. It's going to shut itself down. So, and we have it. Oh, and actually, I screwed something up, because the square isn't selected by that. The square is selected by a player. So, the player gets to select the square. Select square. And as you can see, you have this seemingly very large chain of events just for a simple game of tic-tac-toe. But it all makes sense. You can follow it in one path. So there we go. Start, draw a board, select a square. Was the move valid? Yes. Is it X's turn? Then yes, put an X in the square. Switch players, deactivate the square. Do they get 3 in a row? No. Are there any remaining? No. Oh, I forgot one thing. Oh, yes. Are there any remaining? Yes. It does actually go back to select a square. So you can keep having this go and loop around and loop around and loop around until either we run out of squares, in which case, there we go, we have the no there, or someone wins, and then we'll ask if they play again. So, and I didn't even get into the actual very big, complicated bit here, because really, this get 3 in a row, that's actually really 8 separate questions, okay? I truncated it down to 1, but really, if you think of a tic-tac-toe board here, let me just draw lines, and there's one line, and there's another line, and there's another line, and there's another line. If you look at a tic-tac-toe board, there's actually 8 ways to win. 1 square, 2 square, 3 square, that way. 4 square, 5 square, 6 square, that's 2. 7 square, 8 square, 9 square, that's 3. Or you could do 1, 4, 7. You could do 2, 5, 8. You can do 3, 6, 9. So there's 6, but you also have 1, 5, 9 diagonal, and 3, 5, 7. That's 8. There's actually 8 ways to win tic-tac-toe. So, in actuality, I could take this did player get 3 in a row, and I could make 8 separate individual yes-no questions, just keep going down, 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 to make it more and more complex and fit, whatever it is I need to fit. So, even the most simple games that you can think of, that you played, Go Fish, 21, any sort of game you've ever played as a kid, or tag, anything, when you break it down into step-by-steps, like the way a computer is going to think, it is actually far more complex than you think it is. So, what you have to get used to is realize what has to happen first, what happens second. I recommend you write down all the things that happen in your game, and then you can rearrange them in whatever way that you think it would happen. So, and then once you figure out what it is, figure out your questions. How do you win? How do you lose? What happens if there's a draw? How do you draw? Can you win? Can you lose? How does it start? How does it end? Just what are the potential states you can have? So if someone picks something like poker, oh boy, you have a whole lot of stuff that you have to worry about. But, because there's a lot of different options and stuff like that. So this is just a very simple game, and as you can see, it is still super complex just by breaking it down into step by step by step by step by step by step. But you can always break down anything, no matter how complex, into yes-no questions. Now, there may be a lot of yes-no questions, but you can always break it down into a yes or a no question. Because how do computers think? They think in on and off, yes and no, true and false, 1 and 0. That is binary. That is the basic understanding of computers. Every single complex algorithm they have, at its core, is based off of yes and no. So if we can break down our logic into that and understand what we're doing, then we can code anything. Thank you very much. This concludes this lecture. Hope to see you in class.